Hello everyone. This is Sendil Kumar, Assistant Professor, Erode Sengunder Engineering College. In this today's session, we are going to discuss about software engineering. In this session, we are going to see about the fundamentals of software engineering and requirement engineering. Everybody to know about the software engineering. Software engineering is a very important subject. So everywhere in the all over world, we are having the so many competitions, and everywhere software is going to be developed. The part of the software development is going to be manual work is going to be automated. So that's why nowadays software is plays a vital role in all over the world, right? So in this video, before jumping into the main content, we would like to say about these are all the things we are going to focus. Okay. This is the topic: fundamentals of software engineering and requirement engineering. We are going to see one by one. This is software engineering fundamental. Okay, the first of all, we would like to say about the term of software engineering. Software engineering is a composed of two words, that is software and engineering. Okay, software is called as just a program, specifically we are going to solve small oriented problems, so that's why we need a program. So program is a piece of code. Okay, whatever we want to solve a small oriented problem, so that time we are going to create a code, so that is called as the uh, program. So this is collection of executable programming code, associated libraries and documentations, right? So software is when made for a specific requirements is called software products, right? So once the software is a collection of huge modules and all things, it's a very big task, right? Big oriented task is going to solve using the software. So wherever need the software, after the software development, that should be implemented there itself. So that is why nowadays software is doing in a very important role. Okay, so another case, this is called as engineering. Engineering is nothing but on the other hand, so this is a very important. Okay, uh, so this could be cover all the scientific principles and methods, and also gives provide this systematic way of approaches and all things. These are all the characteristics of software. Okay, while focusing on the software, these are all the characteristics should be focused in a very primary way. Software is developed or engineered. Okay, this is it is not manufactured in the classical sense. Not at all. For suppose we compare to every product, so every product is going to be manufactured, but here is software is only the developed by the software engineers, and followed by the, some of the manufacturing software engineering divisions. So this is called as, this is software is developed, okay, or engineer, they're not manufactured. These are all the important characteristics when focused to the software characteristics. It's very realistic and very flexibility and gives the lot of advantages. Okay, while these are all the things should be focused in a right way. Software does not wear out. Okay, does not wear out. Once the software is have to plan to develop, in the sense they definitely we have to do some of the gathering the requirements and analyzing in a proper way. It depends upon our problem. So based on that, we are going to do all the work in a sequence manner. Once if the overall software is developed, okay, after that there is any corrections, if there is any risk, in the sense it is not wear out. So it is we need to correction, we need to do some of the enhancement, and we have to do some of the changes, and go for the next process. Okay, although the industry is moving toward the component based constructions, most software continues uh, to be the custom built. Okay, custom built in the sense it depends upon the customer, then depends upon the industry needs, then depends upon the what are all the things to be automation. So based on that, software is going to be developed. So these are all the important characteristics of the software. Okay, so this is the difference between program and software. Okay, I said earlier, program is a very small size, software is a very large size. Program is going to be authors himself is users all. Okay, this is the large number because the collection of modules and the task, in the sense the small task is called as a program and big task is called as a software. This is what the exact difference between those two things. Single developer. Okay, program is developed by the single developer. It's a team developer. Okay, okay, whatever the software confirmed from the client side, the manufacturing division is going to be allotted the manpower. So that kind of manpower is divided into the some of the team. Okay, based on the task allocation, the team member has to be uh, work in a right direction to the so going to solve that particular task. Okay, program is called as the adopt. Development is a systematic development. So here, the program is a lack proper interface. This is the well-defined interface. Okay. Oh, a program is developed by based on the algorithm and all other diagrams and all other predefined things. Then a single developer is going to develop a program. This is before get this software development. That should be well defined and interface. Okay, properly analyzed and collecting the data without any delay from the customer side. Oh, this is here large proper documentation. This is the software is called as a well documentation. Okay, based on documentation is very important as per the software engineering concern. Okay, while before developing the software, everyone should be get ready for the document. What are all the things going to done? Okay, so this is called as software application domains. Software application domains in the sense. Um, what are all the softwares available? Okay, here we are having some of the types of softwares in our screen. First one is this system software, application software, and so on. System software is called as a collection of programs written to the service other programs. Okay, system side execution that is called as a system software. Oh, like operating system and all things. Okay, without operating system, we never run any computer. So that's why here is a good example for system software is called as operating system. Then another case, this is also called as the developed by the software developer and installed and or running within the system. Itself. So that is called as the system software. For example, um, compilers, editors, and file management utilities. Then the other network management, ideal administrations. So that kind of things is called as the good example for the system software, right? So this is next where we move to the application software. Application software is a standalone programs. Okay, a problem is going to be solved as specific business requirements or needs. Okay, some of the customers is doing business, so that kind of things. Entire business is going to be automated, so that's why that software is cover all the business requirements. Once the application software is developed, and that should be implemented and installed into the customer's spot. Okay, customer place and immediately gives the uh, solve all the business and other related problems. Okay, application in the sense this is the area process business or technical data. Okay, yeah, where that facilitates business operations and management. So every application software should be focused on the well decision making and all other things. So this is called as, for example, the library management system or college management system. Then real-time web applications also nowadays running, right? Okay, these are all the what are all the systems are running over the internet. That kind of software is called as the what? There's a web-based applications. Okay, so these are all the system softwares and application softwares. So engineering and scientific software. This is the third one. This is a special type of software. So going to be implement the concept which comes under the engineering and scientific notations. Right, the applications only focus on the engineering and scientific. So that is called as the engineering and scientifics. So these are all the things, computer aided design, system simulation, and other interactive applications. So have begin to take the real time. Okay, wow, what are all the things carry over to the real time? So that kind of software is called as engineering and scientific software. Most probably this kind of software is running over the internet. Okay, next fourth one is the embedded software. So embedded software is a very important one. This is resides within the product or systems, and it's used to implement and control features, so that all the functions should be covered. Okay, whatever the end user functions cover, so that kind of software. Okay, this is also running the system itself, example keyboard control and other microwave oven and all things. Okay, so next, web application, you know that the piece of code running over the internet, so that is called as web page. These are very huge competitions nowadays all over the world. So everywhere, everybody moves over the internet and do something. So that kind of things we need an application. So that kind of application is called the web-based applications, and also web applications are evolving to the sophisticated computing environments that is not provided to the standalone features. Okay, it is should provide into the computing functions content to the end users. Okay, these are all the, so the after the once the application is developed, that should be carried over to the internet and so implemented that itself, that should be we can able to access all over the world. So that kind of software is called as application softwares, right? Nowadays the Gmail and all other services is called as the real-time example for the web applications. Okay, so this is the fifth one. Next, artificial intelligence software. This is a very, it's plays a very important role nowadays. Everything moves to the artificial intelligence, right? So it is going to create a machine intelligence. Okay, we are going to make a machine as an intelligence, so that is called as artificial intelligence. Going to makes use of the non-numerical algorithms and also to solve complex problems, that everything goes to the straightforward analysis, right? So applications within the area includes the robots, expert systems, pattern recognition, in the sense that there is image and voice, and artificial neural networks, and theorem proving and game playing. These are all the called. And nowadays, the game playing, in the sense the live streams comes from the internet. Okay, the nowadays the data science plays a vital role, and the big data plays a vital role. So based on that, we are creating a make an intelligent system. So that kind of software is called as artificial intelligence software. This is very important. Okay, so this is the sixth one. These are all the things we have to discuss here for the time various of applications. Okay, next, we should enter into the our main content, that is called as software engineering. Okay, software engineering is called as an engineering branch associated with the development of software products using well-defined scientific principles, methods, and procedures. Right. So whatever the things we are going to do, initially we are going to take some of the ideas and take some of the procedures and referring some other things, right? So every software engineering manufacturing division should be focused on the systematic rules and principles. So that kind of systematic rules and principles should be availed from the software engineering, right? Like the another words, the software engineering is a systematic approach going to give the systematic way of procedures. So suppose we are going to start the software development means you're going to start the development in this way. Okay, start here and go step by step manner. What are all the things initially required? Manpower, procedures, tools, databases, and the other tools. So we every element should be collected in the right direction and focused in the right direction, and going to be solving to the particular business oriented applications in the right manner. Okay, without the tools and techniques, and without the procedure and guidelines, and without the help of the software engineering support, we never develop any kind of software nowadays, because the world is a very going to be very competitive way. Okay, everywhere the software has developed with the help of the software engineering and other principles. Okay, all are thinking about software is developed by the humans without the help of software engineering and other principles. Okay, that is never made. Okay, that's why the software engineering gives a lot of advantage take place here. Okay, so here in the IEEE point of view has developed a more comprehensive definitions, which it states So here the software engineering, every application has to be focused in a systematic and a disciplined, quantifiable approach. Okay, for the development and inside the development. Okay, operation and maintenance of the particular software. So these are all the terms should be focused in a right direction. This is the exact definition of the software engineering. Okay, whether we are going to take the some of the business, some of the task from the end user, in the sense that every that time itself we are going to focus in a very sensitive way of things. We are going to approach the follow the rules and regulations and procedures and the theorems and other systematic rules and models. These are all the things inbuilt-inly available from the software engineering platform. So that's why everyone to go and refer all those things, right? This is the we can see the generic view of the process software engineering for the layer technology. Here we are having some of the elements, tools, methods, process, and quality focus. This is the various software engineering layers. Every layer should provide the important concept. Every layer should be synchronized with each other, connected with each other. Once the tool, in the sense, before start the software development, these are all the engineering layers should be focused in a very important way. Tools, in the sense, the resources and what are all the things required for the software development. Okay, methods, what are the methods and procedures we are going to follow for the software development. Process means once the software has to be start for the development, then next what are the things we are going to do. So everything should be predefined, right? Based on the predefined approach only, every software engineering development will be carried forward to the next level, right? Yeah, quality focus. Quality is much more important. Okay, every software engineering division should be has focused very quality as a primary factor. Whether the after development, after implementation of the software, the quality should be matched with the 100%. If once we are getting the 100% of quality, that kind of software is called as the great level of quality. Okay, these are all the things. This is the layer technology. Next, in the sense, the software engineering is a these are all the points I said earlier. Okay, we are going to focus on the quality, and we are going to focus on the process, and we are going to focus on the various methods and tools. So every everywhere, and also this is the modeling activity. Every model should be plays an important role. Before started development, we should refer, we should take, and we should follow the any model of the software development as per the software engineering principles. Methods encompasses a broad array of the task into the include communication, requirement analysis, design modeling, program construction, testing, and support. This is the methods. Five methods, important methods should be focused in a sequential manner before the software development. So also we are having some of the tools to provide the automatic or semi-automated support for the process and methods. Tools plays a vital role. Okay, so everyone should be synchronized in the right directions, and what are the support, technical and non-technical supports we are getting from the right source, and so there is any common based or computer aided software engineering based things available, means we are going to take initially for our software development, because once the software has developed, it means we never do anything later. So that's why we have to do all those things in before the software development. Next, software process must be established for effective delivery of software engineering technology. So this is the process framework. Framework, in the sense, the some of the umbrella activities. Okay, where we are going to start, where we going to we're going to finish initially, how we are going to pass each and every levels. So that should be established and predefined earlier, right? So software process identifying in a right way, okay, and followed by the some of the right framework activities. So other case, the software process framework encompasses a set of umbrella activities. So that is exactly suitable for applicable across the entire software process. Each framework activity is populated by a set of software engineering actions. So software engineering actions is represented by the basic number of different tasks set. So every software has big task is divided into the some of the simple tasks. So each and every simple task uh, has developed in the various places. Okay, definitely every task should be reach our milestones. Every task should be preset target should be reached after the development is over. So these are all the software process activities. So initially, this diagram will shows us the very important concept and points to us. Basically, this is for covering all those levels. First one, the process framework. So encompasses into the all the level activities. The collection of activities should be merged with here. Then umbrella activities. Activities in the sense the big task is divided into the sum of the small tasks. So that is called as each and every task is to be called as the activity. Here we can see the framework activity 1 and framework activity 2 and framework up to framework activity n. Okay, for example, we are having 10 activity means just we can give the 1 to 10 order, right? So software engineering action and gives the set of task. Inside the task, work task and work product and quality assurance points and project milestone and all things. So other case, software engineering task going to be focused on some of the quality assurance points and as well as the project milestones and all things. So based on the each and every activity should be moved to the next levels. Finally, end with the framework activity and so after the task is over, the every task should be focused in a right direction with the help of all the principles and procedures which is given by the software engineering. The generic process framework software engineering encompasses the five activities, right? So here, these are all the things are very important during the development of the small programs, the creation of the large web applications, and all other small web applications. Here, the system is focused in a very important way. So, communication planning, modeling, and construction deployment. Okay, this is five consecutive activities should be focused for software development. Okay, we are going to see one by one. Communication is the activity which properly establish and properly identify the end users, stakeholders, and what are all the requirements we need to gather from the end users. And every software engineering division should be maintained and touch with the end user in a smooth way of things and maintain the relationship in a right way. Okay, planning means once they get a requirement, all those things from the communication part, that should be this is the next part. We have to plan, okay, technical, non-technical, other related things, how we are going to solve the problem. This is our task means how we are going to take the task into the next level, what are the skills required, what are the risks we are going to face, the basic required resources. So everything should be analyzed, manpower and all things, right? So this is the planning is very important before jumping before developing into the software. So planning is a very important. Okay, based on the planning only we are going to do all those things in a sequential manner. Modeling is about the building representations of things in the real world, right? Model and the sense that are prescribed um, things have to be implemented, okay, already. So that kind of things, that kind of activity we are going to follow step by step manner. So once we are getting for the reference by each and every model means this should be gives us the better understanding of the requirements. Okay, where we are going to start, how we are going to do our next step. Okay, if there is any risk means how we are going to face. So everything should be focused by the models. So that is the theoretical approach. Every software development should be focused in the models, right? Without model we never develop any good software. Next, construction. Once the communication planning and modeling part is over, means just we enter into the constructions. All those three previous level service provide to the next level. That is called as construction. Construction is going to develop a software. This is called as a entire part of entirely focusing on the application development. By construction is focusing on the set of procedures and rules, whatever the things required. Okay. So our next level of software development is focused, right? Deployment, once the software is over, then designing is over, and then focusing on the coding, then coding is over, next testing will be conducted. Once the testing is over, next phase is called the deployment. Okay, deployment is the activity. Okay, once the uh, carry over to the next level, right? Install into the customer place, then getting feedback and other things should be focused in the deployment area. So these are all the five things should be focused in a very important way. So these are all the frameworks activities. Okay, every software is called as the uh, umbrella activities, software product tracking and controls. So this should be allows the software team to access the program against the project plan. Okay, what are all the necessary actions, what are all the necessary things to be focused, how we are going to manage the tracking of the project, how we are going to control the our software development. So everything will gives from the umbrella activities. This is the right source, this is the right data collection from the umbrella activities, and we should be followed in the right direction. So inside the umbrella activities, that should be, this is the risk management is important. How we are going to face the risk, how we are going to affect some of the unnecessary things in our program. So once the risk is identified or initiated, means that definitely quality will be focused. Quality going to be reduced. Software quality assurance defines a gives the quality of the software. Based on the quality only our development, our entire software is gives 100% quality, means reach our target 100% means, yeah, definitely that software gives ensures the 100% of quality. Technical reviews, we are going to focus on the, some of the technical reviews and all things. So this is the going to remove the errors before they are propagated to the next activity. Measurement is the assessment process, going to assess everything. Okay, whether our reach our quality is 100% or not, and we have to reach and meet stakeholders needs and all things. So these are all the things this session we are going to cover from the starting onwards. So remaining things, yeah, definitely you are going to follow videos, follow my videos. Remaining things will be discussed our next video. Okay, thank you all.